So just like we can use our calculators to graph y equals an equation, let me see what we have here. We're in polar coordinate mode. So I can go to mode, change this back to function notation, and we have y equals showing. This is how we graph our normal rectangular coordinate plane functions. So if you wanted to graph a polar function, change your mode, go down to polar, enter. Whenever you hit y equals this time, the y's change to r's. Okay, so that's how you know that you're in the polar mode instead of the function mode. So let's look at this example. Write the Cartesian equation x squared plus y squared equals 9 in polar form. Well, what you have to remember are those two little formulas. X is r cosine theta and y is r sine theta. And what you want to do is switch out the x's and the y's for the r's and the thetas. So we have x squared plus y squared is equal to 9. So simplify this. That's r squared cosine squared theta using the rules of exponents. R squared sine squared theta. Both of these have an r squared, so you can factor that out. Remember, cosine squared plus sine squared is equal to 1. So you have r squared times 1 equals 9, which means r squared is 9. If you take the square root of both sides, you have r is equal to positive and negative 3. This is actually the polar form of that equation. So how does this look if we were to graph it? There are pictures at the bottom of the page, but I want to show you how you get that in your calculator. So I've already changed it to polar mode. I just want to put 3 and negative 3. R equals positive and negative 3, and graph it. We have a circle. That is represented here in this example. Okay, so how would we test the other one to see if they actually look the same? Well, the first thing that we have to do is solve for y. So we'll subtract x squared and take the square root of both sides. So we get y is equal to plus or minus the square root of 9 minus x squared. So now we go to our calculator, change the mode back to function. Now we have y equals. We want to change this to a positive square root of 9 minus x squared and a negative square root of 9 minus x squared. Hopefully we'll get a similar picture as our last one. And there we go. We have a circle of radius 3. Over here we have a circle of radius 3.